so we are going to do this example. It says, follow the steps for graphing a rational function. So we are given a rational function. Let me go ahead and I need to go to draw. And then this is a rational function. And the first thing that we will need to do is try to factor it. All right. So I think this is kind of far from my face. Trying something new. Hopefully it works. So what am I doing? Oh, yes, we are factoring. So if you look at the numerator, there's nothing to do. So that's going to stay. Cannot factor that anymore. It's just 5. 5 times 1. But in the denominator, this is the difference of squares. Perfect squares. So if I factor them, I have now Rx equals 5 over parentheses, parentheses, square root of x squared, x and x, plus or minus, plus and minus, and then square root of 4, square root of 16, 4. I have that tendency sometimes too. I'm asking a question, instead of asking the question, I answer. It's just bad. So now this is the rational function in factor form. And then the next question asks you, what is the domain of our function? So I have it here because I need to make this a little bit thicker. I feel like it's maybe too skinny. Okay, so the function again, I'm just going to write it right here. Oh, it's still very skinny. I'll change it in a minute. I have 5 over x squared minus 16. So if I need to find the domain, I am going to take the denominator, because this is a fraction, rational, and I'm going to set it equal to 0 and solve for x. Okay, so we already factor in the first part. So we know that this is x plus minus 4 and 4. And because it's equal to 0, we set both equals to 0. And we solve for x. So we have x cannot be negative 4. X cannot be positive 4. Okay, if you didn't want to factor, you could have add the 16 and then take the square root of both, and that would leave you with plus or minus 4. So if we write this in interval notation, I'm going to just write right here. So I go from negative infinity to negative 4, union, because I need to be able to connect the intervals. So then I go from negative 4 to positive 4, union positive 4 to negative 4. Now this is including everything except negative 4 and positive 4. Okay? Now the next question is, write it in lowest terms. Well, if you notice, once we factor it, nothing cancels. There was no binomial, no monomial, nothing cancels. So it's already in its lowest form. So already in lowest form. All right. Cool. Now let's go to the next question. It says locate the intercepts of the graph. So we need to find our x-intercept and we need to find our y-intercept. Okay? So my function again is r of x 5 over x squared minus 16. I'm going to start by finding my x-intercept. Therefore, I am going to set the y equal to 0. So y is r of x. So I am saying 0 equals 5 over x squared minus 16. Okay, I'm solving for x, so I am just going to go ahead and put this over 1. And then I'm going to cross multiply. So 1 times 5 and 0 times x squared minus 16. When I do that, I have 0 times x squared minus 16. That gives me 0. And then 1 times 5. That gives me 5. Well, I am left with this statement here, which is not true because 0 does not equal 5. Therefore, this right here do not have any x-intercepts. That means that this function does not crosses the x-axis. All right? So no x-intercepts. No x-intercepts. Okay, I don't want to have to keep writing the whole word, but there it is. All right, so now we're going to find the y-intercepts. Okay, so I'm just going to rewrite the function again because make sure we are understanding what we're doing. All right, so I am looking for the y-intercept. Therefore, I am going to substitute 0 for the y, for the x. 0 for the x. Okay, so I have r of 0 equals 5 over 0 squared minus 16. So then r of 0 equals 5 over 0 squared gives you 0 minus 16, that gives you negative 16. So your y-intercept is the point 0, comma, negative 5 over 16. And I believe this is 0.31, 0.31, negative 0.31, which we'll work with that later on. All right, so no x-intercepts and we have one y-intercept. Okay, let's go to the next one. I feel like I am out of breath because I am trying to rush, because the last time I did a video like this, it was over 15 minutes. Okay, so where are we? Determine the behavior of the graph. Any of the x-intercepts? No x-intercept. No x-intercepts. There we just have to say that. For this graph, the graph does not touch the x-axis, therefore no x-intercept, therefore no information about behavior when it approaches the x-intercepts. Next. Okay, now we need to determine the vertical asymptotes, and we actually kind of already have this, but I'm just going to go ahead and write it out here. Okay, so my function again is this guy. Okay, and when we found the domain where we took the denominator and set it equal to 0 and solve, and we got positive 4 and negative 4, those are our vertical asymptotes. Okay, so I'm just going to go ahead and write it here as well so we can see. 4. So we have a vertical asymptote at 4 and we have a vertical asymptote at negative 4. Okay. Next. All right, so the next question will say determine if there's a hole, if a hole exists. So when we have a rational function and we factor it, and there are terms that cancel out, like you have, let's say at the top you have x minus 3 and at the bottom you also have x minus 3, and those two will cancel out, so it reduces. Those terms that cancel out, that is a hole. All right, so think about a road and there's like a pothole in you're driving and a little bump. Think about it like that. The function still continues. Oh, why my camera? Okay, the function still continues, but it's just there a hole exists. In this case, that didn't happen because we didn't have to cancel anything. Therefore, no holes. Okay. And then it says determine the behavior of the graph on either side of the vertical asymptote. All right, so we have x plus 4, and we also had x minus 4. Okay, and that was equal to 0. The multiplicity for both of these ones are 1. Therefore, this is odd multiplicity. Okay, so when we have that scenario, I don't know if I want to write it. I feel like it's a lot of writing. In the other video, I was kind of tired. So, but let me see. It says, I will write this statement. So when it's odd multiplicity, our graph will look something like this. Okay. This is like the start, okay? It's not always going to just have 2, which you'll see for this example, but it will have where one graph is one end and the other one is mirroring it, like on the other side, on the other quadrant. So it's kind of like, I don't know if this is kind of like, mirroring each other like that, okay? I cannot do that, but it will look something like this, okay? So the graph will approach positive infinity on one side of the vertical asymptote and negative infinity on the other side. Let me write this statement for you. I'll do my best. Okay. And this is how it's in your homework. And I want to make sure we pick the correct one. Okay. If I misspell something, it's because I am trying to be fast. Okay. Don't want you to be for too long watching this video. This is vertical asymptote. Okay. And positive infinity on the other. Okay. My writing is so bad. All right. Let's go to the next one. Oh no, already 10 minutes. This is takes forever. Okay, determine the horizontal asymptote if any exists. Okay, so let's think about if we remember our rules with horizontal asymptotes. So let me write the function again. I have it right here. I was going to write it for every part, but then I was like, just write it in. That way the students don't feel like it's a whole new problem, okay? So for the horizontal asymptotes, in this case, the degree of the numerator is less than the degree of the denominator. Therefore, we have a horizontal asymptote at y equals 0, okay? So remember, right here, I don't see it, but it's there. This is x to the 0, okay? 0 definitely is less than 2 right here, okay? So we have a horizontal asymptote at y equals 0. It's important that we know our 4 rules when it comes to horizontal or oblique asymptotes. Excuse me. Okay, so what are we doing next? Okay, this is simple. There is no oblique asymptote because we have a horizontal asymptote. Okay, next. We are only missing 2 parts and we are about the same time. Determine the point, if any, at which the graph of R intersects the horizontal or oblique asymptote. So our function is R of x, go back to black, equals 5 over x squared minus 16. We have a horizontal asymptote at y equals 0. So we need to determine if it intersects. So let's figure out when y is 0, what will be the x value? If we do get a point, so therefore there's a point of intersection between the horizontal asymptote and this function. So I am simply going to substitute 0 for y, which is r of x. And this is going to seem familiar because it's what we did for the finding the x-intercept. Okay, and again, I'm going to cross multiply and I am left with the statement of 0 equals 5. Is this true? This is not true. So the function does not intersect the horizontal asymptote. So no intersection. Oops. Oh, caramba. I don't know how to spell. It says it right here. No intersection. Let me just take the time and do that correctly. No intersection. Yay. Okay, the last part, and we're here are putting everything together that we learn. Okay, so I'm gonna go ahead. We have, as of right now, everything that we have learned from this graph. We have a y-intercept at the point 0, comma, -5 over 16. What else do we have? We know that there's no x-intercepts. We have a vertical asymptotes, 2. One at x equals -4 and one at x equals 4. What else do we have? We also have a horizontal asymptote. I'm supposed to put H. We have a horizontal asymptote at y equals 0. Okay. Now, it would like for us to determine the intervals because we want to graph this function, right? And we want to know at what part, and when we break this down in intervals, where the function is it above or below the x-axis, okay? So I'm going to try, I feel like I don't have that much space, but I'm going to try to put this here. And then you guys already know that I cannot make a line straight. It's just a flaw. I don't think I can even walk straight that well, but you know, it is what it is. So we have this y and x, okay? I have the, let me go ahead, I have the vertical asymptote of a -4, and I have the vertical asymptote of 4. Okay, so I'm gonna go ahead and use, I'm gonna put the red to be just a little bit thicker. Okay, so these are my vertical asymptotes here, okay? And then we also have the horizontal asymptote right here on the axis. Okay, imagine that's on the axis, okay? All right, we have the y-intercept somewhere over here. Okay, somewhere there, right? Cool. All right, so now what we need to do is break this apart into intervals, and we're gonna use our domain for that. So I have from -infinity to -4. I wanna know when I pick an x value in that interval, is that going to give me a positive or a negative y? If it gives me a positive y, that tells me that my graph is right here on quadrant 2. But if it gives me a negative y, that tells me that my graph is on quadrant 3, so somewhere over here. And then I am going to pick the next interval. I'm going to write it right here. I'm going to pick the interval -4 to +4, all right? And the same, I am going to pick an x value, and I'm going to substitute into my function, and if I get a positive y, that means my function is above the x-axis, or if I get a negative y, that means my function is below the x-axis. In the same scenario, it's going to be for my next interval. So 4 to +infinity, okay? Now, I wanted it to do everything in this little piece right here, so I am running out of space. So I'm just gonna write it right here. I did work that out. So on the first interval, when I substitute -5 for x, the y that I get is 5/9, which is positive. Therefore, my graph is going to be somewhere right here, okay? And then on the second interval, let me go ahead and do different colors so we can try to, no, let's not use that. Let's use pink. Okay, on my second interval, I pick x equals, what was it, -1. And then when x was -1, it gave me a y of 5/-15, which is, this is negative. Therefore, it's going to be below. So it's going to be somewhere crossing through that y-intercept and looking down like this. A little bit more spanned out. You know, my graph are, let's not say anything. Okay, you guys know better. These are beautiful graphs. You are imagine fantastic graphs, okay? That's what you're imagining. I have a beautiful artistic skill that does not translate in my work. For the last interval, I am going to pick, what did I pick? I picked +5 because, you know, that would be easier. And then it gave me y equals 5/9. Positive again, very similar to the first one. So that tells me in the last interval, my graph is right here above the x-axis, okay? So if you think about it, of what we were talking about with the multiplicities of the vertical asymptotes being odd, so how it splits. So what you're having, I cannot draw it, but you're having this one. Where is this thing? I have lost my little pointer. Oh, right here. Let me make it bigger. I can point. I can use a pointer. So right here, this one, you can think about it like mirroring this one on this little piece on this side. And the same for this one and mirroring this one right here. Okay. Now, I do suggest if we want to have better view of how these graphs look, go ahead and take it into Desmos and graph it from the beginning and compare your work. But we want to make sure to be able to answer all the parts that are shown in this video. Okay? And this was longer than the other one.